Yeah. Today our topic is to learn about trigonometric identities and equations. Identities and equations, right? Okay. Basically, if you need to understand about these common angles should be known because these are the general figures where we use in our day-to-day life. That means the theta, the general concept of theta should be zero value, angle of 30, angle of 45, angle of 60 and angle of 90. For these trigonometric ratios you should have kind of a knowledge: sine theta, cos theta and tan theta, because these things are generally used in our day-to-day application, the trigonometric identity. So you should have kind of a rough idea. Yes, at least you should know these like some kind of a figures are available for these things. It's commonly used. So if you use sine 0, the value is 0, so you can use a calculator and make sure with that with it. Then if you work out with the cos 0, it's 1. Tan 0 again turn up to 0 with it. Right, okay. Later on I'll explain how it happens. Then sine 30. Sine 30 become half. Then cos 30 become root 3 over 2. And this is 1 over root 3. Tan 30 is 1 over root 3. So these are the general figures where we use in our day-to-day applications. Sine 45 is 1 over square root of 2. This one also 1 over square root of 2. And tan 45 is 1 to this. So you have to understand that these figures are there. Right? Sine 30, sorry, sine 60. Sine 60 is put a root 3 over 2, which is similar to this answer. Then cos 30 is 1 over 1 over 2, that is exactly similar to this, right? Okay. Then this is turned up to root 3. And sine 90 is 1, cos 90 is 0, and this is not existing. You call it a infinity. Infinity means you can say it's infinite figure. Like there's a basic relationships where you should know. And the other trigonometric equations we should know at the beginning is, if you say tan theta is equals to sine theta divided by cos theta. We should know this relationship as well. Sine theta divided by cos theta. If you want, you can, from the trigonometric identities, you can prove this, right? Okay. So basically, we should have a kind of idea of these figures, right? Okay. So key figures are 0, 30, 45, 60 and 90. Those key figures you should know because those are generally we use in our day-to-day applications, right? Okay. For example, yeah, if I need to find the value for, you have to keep this idea, right? Okay. In case if I need to find the value for, so suddenly if I ask tan 30, you can refer to this table. You can say it's 1 over root 3. 1 over root 3, because you can use a calculator as well. But later on today, the concept we are learning here is to work out the algebraic terms. For example, it comes with tan 30 plus k. We need to be able to get some expression for those things. So that is the application of it. For the moment, you will understand the no need of learning these things. The reason is that you can get it from your calculator, right? But
Okay.
later on, we are working with the algebraic terms, just like the different variables adapt to this equation. So with that, you should be able to work out with these figures, because that is highly required for you to analyze that kind of situations, right? Okay. Now, for example, if I need to find tan 120, is there any way I can use this table and obtain answer for this? That is our objective of learning the first part of this topic. Whether is there any way of understanding a figure for this? Right, okay. This is a way of doing it today. For that, we are using some kind of a method called quadrant method. Yeah. Let's see how to use this quadrant method. Initially, what you need to do is divide your page into 4 segments like this. Then divide this into 4 subquadrants, just like this. This is great. just like these four subquadrants, like this. Now you know that today, here the value is 0. This is 0 degrees. When you come up over here, angle become how much? Up to here, it's turned up to 90. Now, is that clear? Right, okay.
Yeah.
Then this is 180. 90 itself, it goes. What is the angle over here, Pate? 200 and?
270
When you come up over here,
degrees.
what is that angle, Pate? That is 360.
360.
Then if you mark an angle over here, I need to find the value for sine and cos value of this. Sine, cos and tan. Here the angle is, if you get an angle over here, that is, you can say 0 plus theta. This is 0 plus theta. 0 plus theta. Right. We need to find some solutions for these things. Right. Okay. Then Pate, if you want to mark an angle over here, just like an angle over here, if you want, you can write this one as sine 90 minus theta. This is, you can say, cos 90 minus theta. If you measure an angle over here, this is tan 90 minus theta. If you measure angle in over here, into this quadrant, this here, over this quadrant, this part of it. So this one you can say sine 90 plus theta. This is cos 90 plus theta. This is tan 90 plus theta. Right. Okay. If you measure angle over here, this part you can say, I just a little bit expand. Yeah, this one you can say sine 180 minus theta. Cos 180 minus theta. Tan 180 minus theta, right? Then if you come up with an angle over here, this is 180 plus. If you mark an angle over this segment, you can say this is sine 180 plus theta. This is cos 180 plus theta. This is tan 180 plus theta. Then if you mark an angle over here, this is less than 270 over this segment. So this is, you can say sine 270 minus theta, cos 270 minus theta, tan 270 minus theta, right? If you mark angle over here, this part you can say sine 270 plus theta, cos 270 plus theta, and this is tan 270 plus theta, right? When you mark an angle over here, you can say theta minus 0 minus, or the basic concept here is, you can say this is sine 360 minus theta, right? This is cos 360 minus theta. This is tan 360 minus theta. Now I need to find the answers for these things today. Right, okay. We know that if you add anything to 0, answer is same thing. So this answer become, I just use a different color. This is sine theta. This is cos theta, and this is tan theta. Tan theta, right? That property will be valid throughout this subquadrant. In this subquadrant, this one and this one and this one, that theory is valid. Therefore, here this value is, you can say sine theta, cos theta, and tan theta. Here also the same thing. Sine theta, cos theta, and this is tan theta. Over here also you can say sine theta, cos theta, and you can say this is tan theta. Right. Then in the other quadrant, in this quadrant, the sine become cos, and the cos become sine. I'll use a different color for that. I'll use just like I like green. Okay. So this is turned up into cos theta, and cos become sine theta. Then this tan become cot theta. Later on we learn this cot theta. Cot theta means 1 over tan theta. Cot theta is 1 over tan theta. Right. So that is common for this one. cos theta, sin theta, and this is cot theta. Okay. Then when you come up over here, here also the same thing comes with it. That is cos theta, sin theta, and this is cot theta. Cos theta, sin theta, and this become cot theta. Okay. Now let's see how to find. There's a little bit extension where we need to know. That means, Pute, in this quadrant, all the answers are positive. In this quadrant, all answers are positive. Yeah. In here, Pute, the angles for sine only positive. The solutions for sine is positive, sine. That means, Pute, this answer is positive, other two become negative. Here, this is positive and other two become negative. That's a factor to understand. Here we call the solutions for cos theta is positive. That means this is positive. This is positive. Other two become negative. These two become negative. Over here, tan theta become positive. Solution for tan is positive. Others were negative. That is the theory we should know. This is negative and this is negative. We use this technique to understand the basic of these values for given angles over here, right? Okay, I'll come up to find the solution for this, right? Okay, then I'll just little bit of minimize this, then you can see the both pages at once. Okay. If I need to find, just I'm going back, same thing, it's like this. Then if you want to find tan 120, I can use this table to find the value for tan 120.
Sir,
Yes.
could I just copy down the diagram?
Yeah, okay.
Yeah, just give me a few minutes.
That's great. Okay.
I'll copy down the diagram.
Right. When you come up with a tan 120, you can write either 120 plus 30 or both approaches are same. You get the same answer. 120, you can say that is tan 180 minus 60. Any format it's okay. Right. Okay. Then if you come up with this, tan 90 plus 30, they are using this format. Tan 90 plus theta. Tan 90 plus theta is how much? Minus cot theta. That is minus cot theta. Theta is 30 over here. This is 90 and this is theta. Cot 30 is, you can say, minus 1 over cot is tan. I told you tan cos theta is 1 over tan theta. Then we can use the previous table, that is minus 1 over tan 30. We already knew this answer from here. Tan 30 is how much? Tan 30 is 1 over root 3. So you can say it's 1 over root 3. So you just use up that value, 1 over root 3. Then this root 3 goes up and turn up to minus root 3. Let's see whether this one also gives you the same answer. Tan 180 minus 60. Tan 80 minus theta. 180 minus theta is minus tan theta. So it's turn up to minus tan 60. Minus tan 60. Minus, what is the tan 60 value? Tan 60 value is, here, tan 60 is root 3. So you get the same answer. So whatever the approach, it doesn't make a difference. You get the same answer back. So now, initially, before you start this session, you have to keep this recorded. Then these two tables are important for the movement to just work out. But this is common for any of the angle, doesn't matter. But anyway, this approach we use. So I'm using the now same technique. Suppose that if I need to find sine 135. So you can use sine. I'm using the both techniques. So both the approaches, not technique. Actually, the technique is same. Yeah. So you can put a bracket if you want to put a bracket. Other than that, not a problem. Tan 135, you can write either sine 90 plus 45 or sine 180 minus 45. Both the same thing. Yeah. Tan 180 plus theta. Sorry, tan 90 plus theta is sine 90 plus theta is how much? 90 plus theta, that is equals to cos theta. That is, you can say this cos 45. This is equals to cos 45. Cos 45. So if you use the calculator for the table, or you can use the calculator even, 1 over root 2. Sometimes if you put in the calculator, you might get this answer, the same thing. Sometimes in the calculator, you might give you this answer. There is a rationalized answer for this. Right. Okay. It doesn't matter with that. Right. Okay. Then sine 180 minus 45. Sine 180 minus theta is sine theta, sine 45. Sine 45 is again 1 over root 2. So you can refer to the table. So you can get this answer. So whatever the approach you use, you can get the same answer further. Right. Okay. Let's go ahead with another question and see. Let's see if I need to find cos. We will get, I'll get this answer. 210. Yeah. So you can use two approaches, cos 210. One approach is you can say this is cos 180 plus 30. Other approach you can say this is cos 270 minus we will get 60. So anyway, you have to start with either 90, 180, 270 or 360, right? Cos 180 minus theta. Cos 180 plus theta. So from this table, you know that cos 180 plus theta is plus cos theta. This is plus cos theta. Sorry, cos not theta, actually it should be 30. Cos 30, we know that it is root 3 over 2, right? If you use this technique with it, 270 minus 60, that one you can say, yes. So this is not minus, it should be not plus, it should be, I made a mistake here. Here there's a mistake, I just made a mistake, sorry. This is not cos, this should be tan. This should be tan, please correct it. And this is the cos one. This is cos theta. So this should be minus, and the so here this should be this mistake with me, Peter, sorry. Just these two should be changed. Just do the corrections over here. Here the tan is positive, but the tan is only positive. So that is, this is positive and this is negative. This is negative and this is positive. All here the cos is positive. Other ones are negative. Do the corrections, please. This is negative. So therefore, yeah, do the corrections quickly, Pratik. This is wrong. It's not the answer.
So should I change down my diagram?
Yeah, to change it because I made a mistake because I just wrote it. Right. Therefore, this is turned up into this bit, cos 210. So this is not plus, it should be, but it should be minus. This is minus cos 30. So it should be minus root 3 over 2. So this is cos 270 minus 60 is minus sine 60. Minus sine 60 is again minus root 3 over 2. Right? Like that, you can get this answer. Right. Okay. Then, yeah, like that's how you need to do it with it. Then the next one is just like this. You get sine 300. Sine 300 you can write any format, 270 plus 30, or you can write sine 360 minus 60, right? Then you can write this is sine 270 plus 30. That is sine 270 plus theta. It's 270 plus theta is minus cos theta. That is minus cos 30. Minus cos 30 is equals to minus cos 30. Cos 30 is root 3 over 2. So if you use the calculator even, you get the answer. Yeah. Then over here, this is turned up into minus sine 360 minus theta is minus sine 60. So that is turned up to minus root 3 over 2. So that is the way of getting this answer. Okay. Yeah. If I need to find sine 390, we know that quadrant method, if you travel for 1, 3, over here, it's turned up to 360. That means this is again 390 means another 30 has gone up. So this is similar to how much? Sine 30. Sine 30 you can put into the value for half. So simply you can get this answer, right? Okay. Then if you need to get this bit of it, then cos, if I need to get this way, 480. 480. That means, Pute, if you start from here, if you go to one circle, 360 gone, another 120 has gone to this side. This is similar to then cos 120. Then cos 120, you can say cos 90 plus 30. Cos 90 plus 30, you can say minus sine 30. That is turned up to minus 1 over 2. Or other than that, even you can use other technique even. So if you just put straightforward cos 480 into your calculator, even you get the same answer back. Right. Okay. Let's go ahead with another example. So if you get it, come up with sine 660. 660. That means, Pute, if you travel a one complete circle, 360 goes, if you subtract 360, another 300 comes. That means from here, it's just like this. Then this is similar to how much? Sine 300. Sine 300, you can write sine 270 plus 30. Sine 270 plus theta is equals to, you can say, minus cos 30. Minus cos 30 is minus root 3 over 2. Right? So if you just put sine 660 minus root 3 over 2, that's how you get it. Put it. Let's go to another extension. If it is a question like this, put it. Sine 765. How do you supposed to do? That's a problem where we have to come across. Right. We know that if you travel a one circle, how much is it? 360. If you travel another circle, how much? Turn up to 720. At 720, again come up to 0. So at a one circle, 360 come up to 0. Again, it's like this. Therefore, this is turn up to another, how much it has gone? Up to here, one circle, 360, two circle means 720. Another 45 comes to this side. So this is similar to sine 45. Sine 45. Sine 45 is equal to 1 over root 2. That's a simple answer for that. The simple way of doing this, if you happen to see this, initially, just how to do this, how to understand, how to do this question. Just sine 765. Then divide 765 by 360. That gives you how many complete circles are there. Let's do this and see whether you will understand that if you do it, it's turned up to 2.125. That means there are two complete circles. Two complete circles. Two complete circles. That from therefore you can just do 765 minus 2 times of one complete circle is 360. There you get 765 minus 720, that is 45. That is how I just get this 45 over here. Right, okay. Now let's go ahead with another example and see whether how to do this progress. So if you want to get just like this, cos 1960. Sorry, 1920, right? Let's see. Then what you need to do is divide 1920 by 360. That gives you how many complete circles are there. 1920 divided by 360. That is turn up to 5.33. That means how many complete circles? 5 complete circles. Therefore, 1920 minus 360 into 5. Then if you work out, you get the answer. That gives you 120. Then this is similar to cos 120. Now for cos 120, you can say cos 90 plus 30. Cos 90 plus 30 is equals to minus sine 30. That is minus 1 over 2. So that is the answer for this. So if you want, you can just put it to calculate and see whether you get the same answer back. Yeah, it's minus 1 over 2 would be the answer for that. That is the way of identifying. So whatever the angle, you can find from your using this technique. But that's a way of doing this, right? Okay. Yeah. I'll make it a bit large. Is a way of doing that. Okay, Pate, right. Yes, over here, Pate, right. Then, yes, now we know how to do any kind of situation somewhere like this. Pate, right? Okay. Then that is the fact where we have to understand. Over here, we already, in the last class, we already learned how to find drawing the sketching this graph. So from here, you can get these ones given that, yeah. Then over here, what you need to understand is just like draw a diagram to show the following angles make the acute angle OP make the x-axis, right? Okay. So yeah, so if you want to mark minus 80 just like this, or the just the basic angle, they want to draw a diagram only. If you need to draw minus 80 means, one second. It just in a quadrant they want to draw it. So minus 80 means it's in the quadrant diagram. This is 0, minus 80 means toward this side. It has gone to an angle 80 somewhere like this. That is what you mean by minus 80. So like that, any kind of angles, minus 160. If you just don't, others are just easy. That's what I'm not drawing it. Minus 160. We know that it's minus to the negative side of it. If you go to this side, it's minus 0, minus 90, 160 is a value somewhere over here. So this is the angle, you can mark it as minus 160. Minus 160 is exactly similar to trigonometrically how much for it? 0, 90, 180, 220. So whatever the situation, if you write minus 160 or 220, you get the same answer in a trigonometric relationships. That is the fact they want to worrying about this kind of situations. State the quadrant that OP lies on the angle the OP makes with the positive x-axis are 400. If you want to draw 400, how it comes with it? 400 means it's just like this. If you start from here, up to here is 360, up to here is 360, another 40 comes to this side. So this bit should be turned up to how much? 40. This is the quadrant format you measure with that angle of 400. So those are the main things you have to understand. Others were just basic angles. Now we need to identify, express the following in terms of trigonometric ratios. Sine 240, we know how to do it. If you happen to see this kind of situations, how do you find it? Sine minus 180, sine minus 80, right? So if you need to find sine minus 80, so you can see that that is exactly similar to this situation. It's just like this. This is 80. 80 means from this side we can mark the angle. From this angle become how much? You can say this is similar to sine 0. If this is 80, this value is how much? This value become 10. 90, 180, 270, another 10 is 280. Then this is similar to sine 280. After that, you can use your calculator and you can obtain the answer for that. Sine 280. If you want to get the value become minus 0.984. Minus 0.984. From here, you can get this answer in that format. They ask you to just represent of it using the calculator. You can find these answers, right? Like that, you can get this any kind of figures with it, right? Okay, if you come up with other these questions, you can use it using trigonometric relationships, and you can get this answer, right? Given that, so if there are any other hard questions, yeah, if you come up with this, how to find it? Sine, how to find sine 450 and sine minus 450? That's the important point with it. If you need to find sine 450, sine 450 means put it just like this. From the quadrants, if you start from here, 360, another how much Pute? 360 plus another 90. 90 is over here Pute. 360 plus another 90. That is similar to sine 90. That is how much? Sine 90 is 1. Yeah. Then if you need to get sine minus 450, sine minus 450, that means you are going to the other way around. Let's go ahead with this Pute. Right. Okay. If you come up over here like this, 0, minus 90, minus 180, minus 270, minus 360, minus 450. Minus 450 is here, Pate. That is turn up to this side. That is how much, Pate? This is exactly similar to sine 270. Sine 270 you can get from the calculator. Let's turn up to minus 1. It's pretty simple. So you can get this answer in kind of format over here. These things are not that important for us to understand, like but when you're working out with the advanced questions in our A2 level, in our what you call second level, we'll be just learning these things, right? Then how to work sine 180 plus theta, you can get it 360 minus, okay. So over here is this bit with it. How to work out this kind of situation? Sine minus 180 plus theta. That's a way of getting this. Sine minus 180 plus theta. To work out, there is another trigonometric approach where we use, there's a relationship called like this, Pute. Sine minus x. You can write this one as minus sine x. That is another important relationship where we should know. Other one is for the cos, even same thing, Pute. Cos minus x, that is exactly similar to cos x. There is no minus come to the front, right? Therefore, you can write this answer. This is just like sine minus theta like. So this one you can write minus sine 180 plus theta. Sine 180 plus theta is how much? Sine 180 plus theta is turn up into just like this. It's over here. This quadrant, that is minus sine theta. Then it's turn up to finally it's turn up to my sine theta. That's the answer where we're supposed to get, right? Okay. Yeah. Yeah, that's how. Okay, like that you can get these answers, right? But these things are just basics where we have to operate with these things. Yes. Then yes. For this answer, so cos 180 minus theta, you can get it. These things you can get any of these factors, doesn't make a difference. So you can put a minus this bit if you work out cos minus 180 plus theta. Then we know that we can, if you use this relationship, this is exactly similar to cos 180 plus theta. Cos 180 plus theta is minus cos theta. And you can get this answer from the you can use the quadrant technique, and you can see whether you can obtain the answer. That is a way of doing it, right? Okay, then that's how you need to do it, right? Then our problem is to understand about how to solve a trigonometric equation. That is the important point where we should know, right? Okay, yes. Then trigonometric equations. The first trigonometric relationship where we know is tan theta is equals to sine theta divided by cos theta, right? It's a first trigonometric ratio or relationship where we learn, right? Now our topic is to understand how to solve a trigonometric equation. That is the most important topic where most all the years they get one equation from this section. Solving trigonometric equation. This is pretty important topic there. So therefore we have to put more what do you call that, more attention onto this question, right? When we are small, we have already learned this kind of situation. If you want to find sine theta, our question is to solve sine theta equals to 1 over 2. In our ordinary level examination, we just write, okay, very good. Theta is equals to sine inverse 1 over 2, right? Okay. Now take your calculator and tell me what is the answer for sine inverse 1 over 2. Yeah.
Yeah, okay, so just
Get
give
me
me
the
a
answer.
second.
How is that?
It gives me 30.
Yes. Sine inverse 1 over 2. Yes. Then you may get the answer 30. Sine inverse 1 over 2 is 30, right? Then in our ordinary level examinations, we just write theta equals to 1 over theta equals to 30, and you just put underline, and nicely you come home. So you get the full marks for this kind of question. So you just, if you do it in O level, yes, you get a correct, you get the full marks. Right? Okay. But in our A level, we have to understand that this is not only the answer which relevant for sine theta equals to 1 over 2. Right? Why is that? That is the problem where we come across. Okay, right. Then let's see, how do you find the other values? And why do we get another value? How do you get another values for sine theta equals to 1 over 2 apart from 30? That is a fact where we have to understand. Okay. Now we can use our knowledge, what we have learned about our trigonometric graphs. I think you can remember we drew the trigonometric graph of sine theta graph. It's just like this. Hope you can remember how we draw this. That is our last topic. Okay, so here the value is how much? 90, 180, 270, 360, 450, 540, 630, 720, 810, 900, so on goes to this side. This is 0, this is minus 90, minus 180, minus 270, minus 360, minus 450, so on it goes to this side, right? Then we know that this top value is how much? It's 1. The top value is plus 1. Then if you need to find the solutions for half, that means this is the value, this is the point of half. Then if you draw horizontal solution somewhere like this, you can see this is the first solution you get in as 30. This is the answer what you get from your calculator. But you can understand that there are several angles more than this. This side also you get more. Here also you get more. Lot of angles are there where we can see. Right, okay. Then how do you find these values? That's the point. Now you can see there's a one common property where we can see, you can understand that this gap is 30. The same gap available here, 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 all of the way, you get the same angle. The same angle. Right. Then how do we find these other alternative angles? This is the way of getting this solution. So you can say for sine, if the first angle is alpha, just like for this question, it's 30. The second angle you can obtain by, now you can see from here, the same gap is to the left side from 180. The second angle you can find it by 180 minus alpha. The first angle you can, if the first angle is alpha, second angle you can get as 180 minus alpha. Hope you understand how I get 180 minus alpha. Then after that, if you need to find the next angles by this way, you can say theta is equals to theta 3 or whatever, you can say 360 into n plus first angle, like that. Then the next angle you can find by 360 into n plus the second angle. Always we use these two angles as the basic angles. These are the basic angles. Using these basic angles, you can work out for n, where n is equals to 1, 2, 3, so on goes on, minus 1, minus 2, minus 3 goes on. It's gone up to infinity, right? Now let's see the same approach to find the solution for this, right? Okay. Let's go ahead with this. I'm using the again same thing. Then theta 1 is how much? Theta 1 is 30. Theta 2, how do you get theta 2, Pute? According to this one, it's 180 minus the first angle. 180 minus 30 is how much, Pute?
Give you an answer of 150.
150. So this is a second angle, Pute. I need these two as a basic angles, Pute. If you need to get theta 3, which is a way of doing it, Pute. 360 into 1 plus first angle. That's a way of getting this, Pute. It is 390. Theta 4, how do you get it, Pute? 360 into 1 plus the second angle, 150. That is done up to 510. Right, okay. If you want to go further, if you want to find more angle, theta 5. 360 into 2 plus the first angle. That's a theory. It's done up to 750. If you want to go further, theta 6, 360 into 2 plus the second angle, 150. Always remember, these two primary angles we use to find the other angles. It is done up to 870. Like that, you can go ahead with this. If you need to find the negative angles, negative approach, negative values. Negative values, this is a way of getting this. You can say theta 7 because it's end up with theta 6. So you can say, right, 360 into minus 1 plus the first angle. It is minus 330. Then theta 8. 360 into minus 1 plus the second angle. Minus 210. Then if you want to go further, theta 9. 360 into minus 2 plus the first angle. Minus 690. Theta 10. 360 into 2 minus 2 plus the second angle. 150. Yeah, so you can get this answer minus 720 plus 150 minus 570. Like that, you can find any much angles you need to go from positive infinity to negative infinity. That's a way of getting the values for that.
So I think you're muted. So I think you might have accidentally muted yourself.
Yeah, okay. Now it's working, right? That's great.
Yeah.
Then, yes. Then if you want to work out, this is the relationship for sine. Then if you want to work out for cos, how are you supposed to get that? That's a factor you have to understand. For cos, how do you need to work out this? Just, yeah. Then if you need to solve the equation of cos theta, right? Let's see if you want to solve cos theta is equals to, I will get half. Right. So in our the basic angle, it's cos inverse 1 over 2. Right. Okay, that means theta 1 is equal to how much? It's 60. Right. Okay. Then we know that if you draw a cos theta graph, just the line is a little bit crooked, don't worry, but just right. Okay. So the cos theta graph is just like this. Over here, sorry, this graph is kind of weird. It's don't worry, just ignore that. So it's 90, 180, 270, 360, then 450, 540, etc. So this is minus 90, minus 180, minus 270. So on it goes on with it. Right. So this is plus 1. So if you come to the half, means somewhere point here with it. Right. Now you can see this is the first angle what you obtain as 60. Here, right? That means this is the gap. Now you can see there are a lot of angles with this. Yeah, over here, 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 and here. Now you can see how to find the other relationship. This gap you can see if you draw it perfectly, the same gap will prominent over here. This gap and this gap become similar because my drawing is not that good. Other than that, this gap is similar to that. This is the relationship we have used to find out the second alternative angles. This is the relationship. For cos theta, if the first angle is alpha, second angle you can obtain by, if this is 60, the same angle over here. The second angle you can find it by 360 minus alpha. After that, the rule is same. Theta 3, that you can say 360 into 1 plus theta 1. Then theta 2, theta 4, sorry, theta 4 is equals to 360 into 1 plus theta 2. So you can say where theta is, sorry, where it's sorry into n, sorry, n, where n varies from 1, 2, 3, so on goes on with the minus 1, minus 2, minus 6 goes on. Okay. Then how to find this one? Okay, so if we just work out theta 1, theta 2 you can find it by 360 minus first angle is the relationship. Right, that is turned up to how much? 300. Second angle is 300. If you want to get theta 3, it's 360 into 1 plus the first angle, 60. That is 420. Then theta 4. 360 into 1 plus the second angle, 300. That is 660. Right. If you want to go further, 360 into 2 plus first angle, that is 720, 780, right? Then you can go a little bit further. Theta 6 is equals to 360 into 2 plus the second angle. It's turned up to 720, 1020. Right. The negative angles, if you want to get negative angles, so you can go ahead with the 360 to 3 even, you can go ahead. I'm just with a couple of angles only. 360 into minus 1 plus the first angle, that is minus 300. Then theta 8, that is 360 into minus 1 plus the second angle, that is minus 60. Right. So yeah, like that you can go to any kind of terms over here. Now you can see there's a relationship with it. All of these positive angles, you can see it's repeated as negative here. 60 is there, minus 60 is there. 300 is there, minus 300 is there. 420 is there, minus 420 is there if you do it further. 660 is there, minus 660 also there. That is came from, I think we have already learned one relationship at the beginning. Cos minus theta is exactly similar to cos theta. From this relationship, you can obtain these answers here. If it is 300 and minus 300, both are same. 60 and minus 60 are both are same. Like this is the fact where we have to understand from this question. This is the way of doing this kind of a question today. Right. Then now we are learning to how to find the same kind of solutions for tan. Right. Right. Let's see if you want to find the solutions for tan theta. Then we get tan theta is equals to, we will get root 3. That is theta equals to tan inverse root 3. Then if you use a calculator, you will understand that. That is turn up to 60. Right. Then this is the first angle. How to find the other alternative angles. Now you can see the same kind of relationship you can use. If you just, this is, it's 90, 180, 270, 360. We know that for tan, the graph, we already learned how to find the tan graph in last class. The tan graph is just like this, but like this way around. My drawing is not that good, so it should be just like this. Okay. Right. Okay. Yeah. Then the first angle is 60 means Pute, it's a value somewhere over here. Just I will use yeah. It's just like this. This is the root 3 value. That means the first angle become 60. Now you can see the second angle also, this gap available over here from 180 to 160. Then you can use the same relationship like sine cos and sine cos, that is for tan theta. For tan theta, if the first angle is alpha, second angle you can see here, the same angle is 180 more. So it's turn up to 180 plus alpha. That's the relationship. After that, the your rule is common. Theta 3 is equals to 360 into n plus theta 1. Theta 4 is 360 into n plus theta 2. Then you can say n goes from 1, 2, 3 goes on, and minus 1, minus 2, minus 3 goes on, right, like that. So these are the two basic angles. Then you can say over here, it's pretty simple. Second angle, theta 2. Theta 2 become 180 plus 60. That is 240. Then theta 3. How do you get it? You can say 360 into 1 plus the first angle, 60. That is 420. Then theta 4. 360 into 1 plus the second angle, 240. That is turned up to 600. Theta 5. 360 into 2 plus first angle, 60. 780. Theta 6. 360 into 2 plus second angle, 240. 960. Negative side also the same factor there. So you can go a little bit further. You can go for more angles, but I just stop from here. 360 into minus 1 plus first angle. It is minus 300. Then theta 6. 360 into minus 1 plus second angle. Minus 120. Like that you can get any much of negative angles as well. That's a way of finding for tan. Okay, now let's go ahead with some similar type of questions, just like this. Let's see if they ask us to solve. This is the type of question they used to ask. They might give you this kind of situations. Sine theta, sorry, 2 sine theta minus 1. Sorry, we just get initially basic angle. This bracket is not required. 1 second. Yeah, this bracket is not required. We'll come up with a very basic question. It's okay. It's equals to, just like we'll make it as 3 sine theta minus 1 is equals to 0. Usually they used to give us a range for theta. So you can say it's minus 400 to plus 500. This restriction is given in the question, right? Then they ask us to solve. The question is solve of this one. Yeah, right. So you can say sine theta is equals to 1 over 3, right? So you can write theta is equals to sine inverse 1 over 3, right? Okay, then we can get the first angle. So if I use this much, sine inverse 1 over 3. Answer is 19.47. So the first angle is 19.47. Now I'm using the same relationship. So this is the first angle. Second angle you can get for sine. We know that if you just move up to the sine solutions, the second angle you can obtain by 180 minus. Right. Okay. So it's turned up to 180 minus 19.47. That is the second angle. Second angle become 180 minus 19.47. That is turned up to 160.53. This is a second angle. 53, right? Okay. Then we'll go ahead with a little bit further. Then theta 3. Theta 3 become 360 into 1 plus first angle 19.47. That is turned up to 379.47. Yeah, that's the second angle. So we just slip it off. Now, right. Theta 4 is 360 into 1 plus the second angle 160.53. Right. Then that is turned up to 360 plus 160.53. That is turned up to 520.53. 520.53. Now you can see today here our range is maximum is 500. So this value is out of range. So no need of considering this. So you can say this is out of range. Out of range. So no need of working out with this, right? Okay. Now let's go to the negative part of the answers. Right. Okay. So you can say theta, this theta 4 is not there. Therefore, I just start with theta 4 itself. 360 into minus 1 plus first angle 19.47. This answer is minus 360 plus 19.47. It's turned up to minus 340.53. Minus 340.53. Then theta 5. 360 into minus 1 plus the second angle. Second angle is 160.53. 160.53. So this value is minus 360 plus 160.53. That is 199.47 minus 199.47, right? Let's go to the next one because you can go a little bit further. Therefore, just work out with this. Theta 6 is 360 into minus 2 plus 19.47 minus 720 plus 9. I think it is not there. So definitely it's not there. Just I can solve minus 700.53. So this one also out of range. It won't come to the answer. Obvious, this is not there. So we will work out the other one and see whether that one even comes. Theta 7 is 360 into minus 2 plus next angle 160.5. I think that one also not coming. Minus 720 plus 160.53. I think that one also out of range. It's minus, yeah, it's also not there. Minus 559.47. So this one also out of range. Then you can finalize your answer in this format. So the valid solutions over here is this one is valid, this is valid, this is valid, this is valid, and this one also valid. So you can finalize your answer in this format. That's a requirement of this. You can say answers. Answers would be 19.47. The progress is like the sequence is not important. You just write the answers. 0.53, 379.47 minus 340.53 and minus 199.47. This would be your final answer for this. That's a way of getting this right. I'll just make it a little bit small.
Okay.
The entire question at once. Yeah, that's a fact. We have to understand.
So you've muted yourself.
Okay. Yeah, right. Okay. Then let's see another kind of question, just like this. They used to give us 3 sine theta minus 1 times of 2 cos theta will get minus, sorry, plus 1 is equals to 0. We need to solve for the range of theta. It's given for the range of 0 to 360. Then we need to find the first set only because from 0 to 360 only. So we can just work out. So if it is a bracket is equal to 0, so you can say individually 3 sine theta minus 1 equals to 0, or 2 cos theta plus 1 is equals to 0. With this, you can say sine theta equals to 1 over 3. Okay, so you can say theta equals to sine inverse 1 over 3. So sine inverse 1 over 3 is 19.47. So we get the answer in the previous question. 19.47, that's the first angle. Second angle is 180 plus 19.47. So that is turned up to 180 plus 19.47 is 199.47 here. 199.47 is the second angle. So all these answers are okay. So you cannot go ahead with 360 plus because the maximum value given here is 360. So no need of working out with 360 plus. Over here, you can say cos theta is equals to minus 1 over 2. Is minus 1 over 2. So you can say theta is equals to cos inverse minus 1 over 2. So if you work out theta 1, the first angle is cos inverse minus 1 over 2. It is turned up to 120. The first angle is 120. Then the second angle become 360 because cos relationship 360 minus theta minus 120. So second angle become 240. So you cannot go ahead with 360 into 1 plus because the maximum range given here is 360. So with this you can say answers become 19.47 comma 199.47 comma 120 240. this would be a final answer. That's a way of doing this kind of a question. Right. Then to 0. So here also they have given the range 0 to 360. Now let's go ahead with this. According to this one, you can say 2 sine theta plus 1 is equals to 0, or 3 tan theta minus 2 is equals to 0. From here you can say sine theta equals to minus 1 over 2. So with that you can say theta equals to sine inverse minus 1 over 2. Minus 1 over 2. Right? So theta is equals to, so if you work out sine inverse minus 1 divided by 2, it's minus 30. This is minus 30. This is first angle. But you can understand that this is less than 0. It's out of range. But this is not an answer for our final as a final solution. But you have to use this one to obtain the next answers. That is the important point. This is out of range, but you are using these ones to find the next angles. So theta 2. Theta 2 become 180 minus, this is again minus 30 because this angle is minus 30. So theta 2 is equals to 180 plus 30, turn up to 210. So this is within the range. Okay, that's great. Then next part is you cannot go ahead whether to apply for 360 to 1. Yes, we have to apply for this because you can understand it's a minus 30. Then if you go to the third one, this is 360 into 1 plus this is minus 30. Because it's a negative angle, it comes to a region where it's applicable and which is relevant for this one. So these both answers are within the range. So this one also an accepted answer and this one also another accepted answer. Sorry, I just...
Yeah.
Then, yeah, then that is the answer because you don't need of getting for 360 into plus this answer because it definitely is exceeding 360. From here, you can say tan theta is equals to 2 over 3. So with that, you can say theta equals to tan inverse 2 over 3. So that is theta 1 is equals to, that is 33.69 today. 33.69, this one also within the range. So therefore second angle for tan, for theta, for tan, that next angle is 180 plus theta. 33.69. It's a second angle. $213.69. 213.69. So both answers are within the range. So this is also within the range. So no need of going with 360 plus because definitely it will give you an answer where it's greater than 360 only. Here we apply since this is a negative answer. But then you can write the answers become minus that is not there. 210, 330, 33.69 and 213.69. Those are the answers for this question.